Good morning to ladies and gentlemen. So first of all, thank you for registering for our competition. So we hope this event will be beneficial to all of you in the near future. So my name is Lo, and joining me today are Dr. Huzami and also Dr. Fatima from UITN. They are the expert in this field. So now I will go to the event flow. So before we go into detail, so let us refresh the event flow. So first, we already passed the general briefing on October 15, and we having a registration period for all the participants to register themselves into this event. So for today is the MDR online briefing. So we will brief about all the MDR content. And after that, we have the submission of the MDR. So it's on November 27. So after 2 weeks, so we have a screening on this MDR report. And after 1 day, December 5, we will announcement on the selected team. And those selected team on December 9, we have a technical training. So this training will be about 6 hours. So 2 hours for the theory and 4 hours for the training on the ANSYS GMAX software, how to use it and how to design. And after that, we will open for 7 days for the consultation. So if you have any technical question or operation in this software, you can ask your question on this consultation period. So we will give some time for this design and finishing the report, and the submission will be on December 23. And we have a screening on the final report on the 2025 January 7. And finally, we have the announcement on the selectors final team. So those final team will have the final presentation on January 16. So this will be held on MISA KL, and the training will be in UITM. So thank you everyone for your attention. So today's objective is to share what we expected in the MDR report content. So though it is not limited to the content like I show this, the MDR content. So now is my pleasure to introduce our next speaker, Dr. Fatima from UITN. Let her briefly introduce the MDR report content. So Dr. Fatima, are you here?
Yes, I'm here.
Okay. You want me to control the slide or you want share your slide?
I think I better share my slide. Thank you,
Okay.
Mr.
All
Lee.
right.
Yeah.
Thanks.
So I will continue. Sorry, before that, hi everyone. So my name is Fatima. So I will be sharing about the MDR, what we are expecting from the report. So together with me, that going to present in this section is Professor Dr. Muhammad Huzaimi. Let me share the slide first before that. Is my slide visible to everyone?
Yes.
Yeah, okay. So let's continue. Where is it? It's here. So before I go into the content of the MDR, the mission design review, maybe I will be I mean it's preferable to explain a little bit about CubeSat because this competition is related to CubeSat because we are going to design the imaging system based on the CubeSat. So before that, let's allow me to introduce a little bit about it. So you can see here, this is the structure, the example of the CubeSat structure that consists a lot of subsystem. that support the mission. So in this competition, we are going to design the imaging system as the mission of the CubeSat. So in front of you on the screen is actually the 1U size CubeSat. Okay, so you can see here a lot of subsystems that support the operation of the mission. Okay, you can see here, this is example of the mission, which is the camera part, and this is the lens that is protrude from this board, and then it is supported by the power subsystem. We call it electrical power system, EPS, as well as the OBC. It works like the motherboard of the CubeSat, and the antenna, a part of the communication system, together with this radio transceiver, in order to receive the command and also to transmit the image data to the ground. Okay, maybe this is another slide showing how the CubeSat structure looks like. Okay, again, this is another part. You can see this is the internal part of the CubeSat. And talking about 1U, actually, you can also design for 2U. 3U and up to 6U. So how to differentiate this is actually for 2U is the double of 1U CubeSat, as you can see here. So CubeSat is the cubical shape of satellite, dimension 10 by 10 by 10 centimeter. And if you want to focus on 2U, so you are using the 10 by 10 by 20, the dimension of the satellite. And if you want to focus on 6U, so it will look like this. So this is 6U. So in this competition, I suppose we're not limiting only to 1U, we are limiting to the CubeSat. So you can choose the size of the satellite that you would like to use for your mission, imaging system mission. Okay. And this is the exploded view of the CubeSat. So you can see this is the only part of the imaging system mission on board the satellite. All right, and this is the part that we are going to design. Not the board, but the camera together with the lens. All right, why do I explain a little bit about the subsystem of the CubeSat? Because those subsystems also affect on how you design your mission, specifically your camera mission. For example, the communication part, it also actually affect how you design the camera mission. So these are basic questions that we will look into in order to design our mission. For example, forgot to do. Okay, the first one, what kind of mission that we want to have? Okay, so in this competition, we are going for the camera mission. So is it the high resolution image or to find to only capture an image without considering the resolution? So this is up to us. Okay, and the second part, which frequency band that we will operate. So let's say you would like to send a very high resolution imagery to the ground station from the satellite. So obviously the size of the image will be greater. So if you are using amateur frequency, so it will take a lot of times to download the packet to complete only one image. So maybe you will consider high frequency, for example, the S band, C band, or X band. All right. So in order to use this band of frequency, you require to design a bigger CubeSat instead of 1U, for example. So this is the things that you need to consider. And then what kind of communication system we need, meaning that what is I think this is not really important, but this is for your information. Let's say you would like to send in terms of what protocol. So what system, communication system that is suitable to use that kind of protocol. Okay, again, the fourth one, the size of the satellite. Is it feasible to use that kind of camera with that size of lens on board 1U? Or is it feasible for only 3U and above, right? So this is depend on our design, needs to be considered. And also the power, how much power that will be used specify that camera system. Let's say your camera system is very small. It is applicable to be put on board 1U size of satellite, but the power consumption is greater. So 1U couldn't provide that much of power, so you need to use 2U or above. So that is the example of consideration in order to design the imaging system mission. Another subsystem that you may also look into is the attitude control, because this is also affecting how the lens will capture the image. So we don't want to get the blurry image, even though it produces a high resolution. So the attitude control will also need to be taken into account in order to design the imaging system. But we are not actually focusing too much on the subsystem. We just to make sure that the mission that we're going to design is feasible, is suitable, is logic for specific size of CubeSat that you're going to choose. And this slide shows the example of how you show the mission specification. So this is just an example. This is the theory that you have to look into in order to design the imaging system, the camera, the lens. So you need to look into the focal length, all right, and the width of the sensor, usually in mm. And then you need to consider the FOV, field of view, that also affected based on the altitude or the working distance. This is also give you the horizontal and vertical FOV. So later, this part will be, I think you will know how to look into this term, because this is very important in designing the camera mission. So in order to understand this, maybe you need to include this specification to show how you get the GSD, how you get the FOV, based on the sensor size given, based on the pixel size that you design or you choose from the market, and what will be the altitude or the working distance. The working distance or the altitude is between the satellite to the ground of the Earth. Okay, so based on this, you can see that we choose the high resolution camera because it's produced this GSD with feasible FOV. Because if we choose a very small FOV, so the size of the image will be smaller, and we're afraid that the image is not really clear. So you can see what we call it the logic between in terms of this. And we need to also see whether the mechanical part of the imaging system is feasible to be put on board the satellite. As you can see here, we look into detail where to put the camera. So by considering all the subsystem in the satellite, we said that we can put it here. Okay, this is also based on the center of gravity that have been calculated. Of course, in this level, you don't need to calculate the COG, but just to show, is it possible to be put on the CubeSat? So you can also rely on the any manual as the reference. As you can see in the slide, we are referring to the Japanese experiment module GEM handbook, where it only allow 6.5 mm extrusion from the external board. So the lens that need to protrude outside need to be extended not greater than the 6.5. So based on this figure, the extrusion from the lens is only 2.5 mm. So this is less than the allowable extrusion given. So this is an example on how you're going to show the feasibility of the mission that you're going to design. And this is also just an advice. This is not necessary, but just to make sure that the design is feasible enough in terms of how the camera produce the image data. Is it big? Is it small? If it is small, it's okay. But if it is too big, maybe it's not feasible for certain um, application of CubeSat, because it may require a lot of pass in order to download the packet of the imagery data, right? So if the greater the size of the image, so it require many passes of satellite in order to download each of the packet image data to complete only one image. Okay, and this is the mission statement example for the imaging system mission. So usually it starts from minimum until full, but it is good if you have extra success level as well. So what is minimum? Again, it's on you. So you have to later to define why you put minimum. What is the criteria that will that shows that the minimum success level has achieved? Okay, for example, here the minimum of success level is just taking images. And if you can take image of the Earth, maybe you define it as the medium success level. So if you can take the image of the Earth with the high ground resolution, for example, so that is full. All right. And if, let's say, you can take the image of Malaysia, so that is extra. Okay, so you define the success level. So talking about CubeSat, I would like to share with you guys, everyone, I'm sorry, the potential mission that we can offer from the application of imaging system. We can also use it for the illegal logging. You can also use that imagery to detect the forest fire, or the observation of the coastal to monitor the turbidity of the water, or also for the agriculture, precision agriculture. So you can see how from the imaging system mission, from the camera mission, there's a lot of application that you can use it in order to ensure that the design of the camera is useful. So what are the benefits of that missions? So you can use it for the DOE, Department of Environment, or Kementerian Alam Sekitar Malaysia. Okay, maybe for security or coastal protection. This is, for example, the Eastern Sabah Security Command, or for fishery, or for the agriculture, as we mentioned earlier, maybe for FGV, and also for the monitoring of the oil and gas industry. Okay, so these are the examples. All right, moving on. So I would like to share on the sample report for the MDR. So what is MDR? Everyone knows MDR stands for the Mission Design Review. So you need to submit some kind of like a proposal for your satellite mission. So what is the satellite? It is CubeSat, ranging from 1U to 6U. So MDR, even though it is kind of like a proposal, you need to include the list that has been presented by Mr. Loh just now. I will show you again the list. This is not limited to that. You can that is the minimum requirement, but you can also present in the report letter more than what we require. Okay, so this is the definition of MDR, how you discuss and develop the mission idea based on your needs or based on the stakeholders' needs, for example. And then the mission idea must are defined based on the system requirement. Later, we will see what is the system requirement that we look into. And then in this phase, MDR, it is the phase that we prove the feasibility of the mission for the satellite that we use. If it is for 1U, so how you prove that the mission is feasible enough for that size of CubeSat in terms of communication, in terms of power utilization, in terms of the dimension, the mass, and everything. Okay, so these are the consideration in the report. The merits is to fulfill the requirement to benefit the humankind and contribute to society, as mentioned in the example of the potential mission and also the benefits. Okay, and the modes, you can present it in the block diagram, the schematic diagram, the flow chart is on you. And then the success level I presented earlier, it started from minimum up to full actually, but it is good to have extra as well. And for the mission mode requirement, okay, this is related to the system requirement, design requirement, and how you verify the feasibility. We will look into this later. So system requirement usually on the how it is functioning, the functionality requirement, and design requirement is based on the operational requirement. And verification, you will see the constraint of the CubeSat and how you map it to ensure that it is feasible, it is suitable to be used on for the CubeSat. And then mission feasibility, you need to look into the size, the interface. I think this one can be omit for a while because it's only the level of MDR. The cost, of course, the weight, the mass, the compatibility of the technology with the CubeSat, and also I think project timeline also, you can also present it to ensure that that kind of mission is suitable or feasible to design in certain timeline even. Okay, so maybe I will share another slide. Sorry, I'm opening another slide. Okay, so the content you can see here, this is these are the contents that are required in the MDR report, but not limited to. The first one is the mission statement. So what is mission statement? The mission statement is defined, is the one that define the mission briefly, as it includes the problem statement, the reason for its conception, and the approach taken to overcome the issue through the satellite application. Right, this is the example of the mission statement. I will tell you more on this mission statement in the sample part. Okay, and you can also see, you can also provide the mission objective. So mission objective is just to tell us the aim or the purpose of the mission, specifically its functionality for the satellite application. So example, mission objective to develop the camera that can capture, process, and store the high resolution imagery. So in this objective, the very significant part is this part, capture and then process and then store the imagery on board. And what image? The high resolution image. So this is the objective that needs to be obtained in the mission design. And then is it? It's not moving on my slide. Sorry. Oh, it's not moving. Why? Right. Okay. So the next one is the mission goal. Sorry, no. The following after the mission objective is the mission requirement. So mission requirement is the part that contains the requirement for performance and functionality of the mission. this is where we talk about the functionality requirement, the operational requirement, the constraint that falls under the system verification just now that I mentioned. So we will see the sample later. And then the camera lens, basic design theory. So you can explain briefly the basic concept of the camera lens that you're going to use in the mission. And then the imaging system architecture, where you can provide the design or the framework or the flowchart of the camera system for the mission operation. And lastly, is the mission goal, as I presented the example earlier, that starting from minimum up to full, and it is good if you have extra level of success as well. Okay. I would like to share the sample. So these are the examples of mission statement that you can use for your mission design letter. Okay, this one has been included in the previous slide. The mission statement is because we know that the issue is about usually the CubeSat only provide the blurry imagery, for example. So you are using the sensor, the advancement in sensor technology in order to produce the clearer imagery. So this is the mission statement. You can see in this first point, you give the problem statement and how you going to mitigate or overcome the issue. The second one is about our country that may be too reliable to others, other technology. Maybe we are the country that that can be called as a reliant user. So we would like to design a system to show that we can also provide the technology where you can cultivate the local expertise, or you want to be to ensure that our nation is the leader in development of this satellite imaging system. Okay, and we would like to ensure that our country advance in the Earth observation. Okay, so you can see in the mission statement there is the problem statement, and there are also the solution to it. But the specific solution is basically based on your mission objective. So this is an example of the mission objective. You can have the primary, you can have the secondary, it's up to you. Secondary is optional. Primary is the main objective. Why you design that mission for that CubeSat. And secondary, you can see is some part, the small contribution to what you have designed. For example, to demonstrate Malaysia capability by producing high quality imaging data. How? By producing the high resolution imagery. Okay, that is the example. Okay. And for the mission requirement, okay, as I mentioned, it can be the functional requirement. For example, here, in terms of the performance, in terms of the coverage. So the performance for the observation mission. So how much of spatial resolution that you're going to produce, that is the performance. You can also elaborate more on this. And then the coverage, the swath area, how big the coverage will be captured using your designed imaging system. Okay, this is functional, how the camera mission will function. So that is the functional requirement. In terms of operational requirement, this is related to the CubeSat actually as well. What CubeSat that you choose? Is it 1U, 2U, 6U? So you need to make sure that the operation relates to that CubeSat. So you need to look into the camera design life, how long the camera that you designed can last, the survivability, okay, whether it can survive in the extreme environment of space, or it also can survive the high vibration during the launching, the mechanical design. So this is very important part where we always look into this, because we want to ensure that the mission, the camera mission, can be put on board that camera. So it not gonna consume a lot of power not gonna consume a lot of space and also mass. So because we need to consider there are other subsystems and also maybe another mission that need to be put on the satellite. So we need to consider this mechanical design. And this is another part that's very important as well, the data acquisition. So you need to tell us how much, not how much, how the operation of the camera, whether it can capture once or it can also capture bursts, uh, burst capturing. So this is also affecting on the design to see whether it's feasible for that spacecraft or not. And in order to validate uh, the system, so we look into the constraint. So the constraints, usually, most of the time, we look into the cost, the schedule on how it's going to operate, the risk, and also the regulation. So talking about CubeSat, of course, we look into uh, a lean concept of satellite where we are producing mission that use low cost but with the effective method. Okay, and schedule, meaning that when the system, the camera system can operate. Is it automatically or based on command? Command meaning that we from the ground, from the earth, send signal to satellite so the satellite can capture um, the image. If we don't send the command, we don't send the signal, so camera will not taking any image. So this is scheduling, how you ensure that the satellite operate its camera mission. And then the risk. So you need to think on the mitigation plan if any expected risks happen during the development, also during the operation of the mission. And the regulation, usually we look into the standard hazard and unique hazard that is stated in the deployer manual. So we need to also refer to the deployer's manual in order to ensure that we meet all the regulations stated. We comply with the regulation. All right. So you need to also present the lens basic design theory. As you can see, this is just example to show your understanding on that lens theory. So from the understanding, usually you will know what is FOV, field of view, what is swath area, the area for the image to capture, and the spatial resolution, or usually we call it as ground sampling distance, GSD. What is the spectral resolution, radiometric, temporal resolution. So when we know the theory of the lens, we also will know about the focal length, and also we work with the working distance. And maybe you can also include the camera system architecture. For example, number of lens, you have 4 number of lens, and then what types of lens, the material type that you use, is it glass, plastic, or anything? And the shape of the lens, is it spherical or any kind of lens that that you can show how you produce that kind of imagery. Okay, this is another example of the mission goal. Okay, starting from the minimum up to full, and as I mentioned, it is good, and we advise you to also put the extra success level. So this is another example where maybe you're gonna use 6U size of CubeSat with this mass 1 kg, and then if you get a blurred imagery but with the resolution of 20 meter, so you can consider this as a success level, minimum success level, because the imaging system is successfully capture an image even though it's blurred. But if it is clear, so you can say it as a medium success level. And if you can produce a very clear imagery, but it is targeting to the Earth, so it is considered at the full success level. And if can target certain country, for example, Malaysia. So we can consider as an extra success level. So again, the success level is defined by you, by the developer. I think that's all from my side. Prof. Huzemi, if there anything you would like to add?
I think so far it has been very well explained by Dr. Fatima. And then for all participants, for the submission of the report, I think organizer will be sharing with you what is it what is it the format in terms of PowerPoint or something else, and then what is it the maximum number of slides, and then we will have a screening session, at least two screening sessions. The first one, because right now we already have certain numbers of participant groups, then we will have first screening, so that those who pass or meet our minimum requirement will go to the second round, whereby for the second round, we will give you the training, plus you will have opportunity to have one-to-one or physical consultation with the company. So you will be invited to the company, and then you will have one-to-one consultation and discussion with the company, how to use the software, and then how to design and everything, the software and the lens. And then after that, those who are then you need to submit a report. Then the final one, we will have a physical presentation at MISA, Malaysia Space Agency, for this one. So please refer to the format of the MDR, Mission Design Review. Then I believe then I think all the organizer, I think all the team members, we believe that you will have will need to have to have a discussion with your supervisors, so that you may provide a good MDR report after this. Okay, and then we are expecting any questions from all the participants here. I think
Maybe
that's all
Mr.
from
Loh.
me.
Thank you, Prof.
Maybe
Zani.
Mr. Loh
Mr. Loh
would
would like to
add
continue.
something. Okay.
Just now, Dr. Huzami mentioned something, right? Maybe I need to have some add-on. For example, let me share the slide. Okay, so just now, Dr. Fatima already mentioned all the MDR report content. So what is the file you need to submit to us is the file you can make in the PowerPoint presentation, and you can save it into PDF format. And maybe the maximum slide will be like 15 pages. Okay, so this is first. And second will be the MDR report evaluation. So the evaluation will be recap for this kind of parameter. We will analyze like realities, and also the creativity and contribution to mankind, and mission related to this camera payload, and the Q set we can design up to 6U. So it's based this 5 point, we do the evaluation for the screening. And another will be the add-on for just now, one of the camera system architecture. So maybe you can write into the detail, like what kind of the field of view you want to design, and what is your F number, and maybe your expected distortion, and also the total length. So this all these parameter will be used on the second after the first screening. So they have a technical training. So after the training, you need to use the simulation tools to simulate the result and use this simulation result into your second report for the presentation. So the layout for the first report you can make by hand drawing, or if you're having some CAD tools, then you can draw it out. So here is a sample. Okay, so is there any question from our participant? Maybe you can post your question on the chat and then we can reply separately.
Thank you, Dr. Fatima and Lo. I don't see any questions in the chat, so everyone who's in the audience, please drop your questions in the chat and use these sessions to the maximum, because I know you have a lot of questions. If you want to ask your questions directly, maybe you can also raise your hand so we can try to unmute yourself. That's also another option. If you want to directly ask your questions, you can try to raise your hand using the options in the menu. A few things to remember. Now, I think we've actually forgot to include one thing in the presentation. Jim, thank you for reminding me this. Your MDR reports should be sent or by email. We will provide you the email address later. So watch out for an email from us. So we will send you the instructions, which email address you need to send, what is the cutoff date, everything we will send you by email shortly. So please check your inbox for this email. Okay, I think we have a question, is it? Okay, the question is, can we take inspirations from previous designs of other developers?
Yeah, if I may answer that question.
Yes, please.
Yes, you can.
Yeah, I think it's okay because you are taking the idea from the previous developer. But you are okay with that, but please present to us how we show that it is feasible, it's realistic to be used for the CubeSat that you're going to use. I think it's okay.
Yeah, it is possible. It's allowed. We just need a feasible mission or idea. For example, if you want to propose sub-meter resolution for 3U, for example, so it's not feasible because sub-meter camera or image will require higher power or higher size of lens. So it may not be feasible, but you may propose what is it the optimum size, what is it the from the previous design or other developers. You can refer to the success story of the satellite developers previously. But if possible, it should be give impacts or benefits to the Malaysian, for example. Thank you.
Thank you for answering that question. If I may, let me add something to that answer. So when you take inspirations from previous designs or developers, same as you're writing a thesis, please make sure to provide due credit in your proposals, or like a citation, if I may. So the evaluators know where or to what extent you take the inspirations from. Yeah, so please make sure to cite it properly if you are trying to benchmark previous proposals or designs. We have another question. Since we are just designing the camera lens, do we get to simulate the CubeSat so that we know that it met the mission goal?
Yeah, I will answer this question. So okay. The answer is yes. So we will provide the software for 1 month trial, and then you can use this software to simulate the camera lens result. So this result will be put on your report. But this is the second report. So after the screening, we will have a training first. And then we have 1 week the consultation period for you to ask question if you're facing any problem in designing your camera lens.
Thank you, Lo. Yes, as Lo mentioned, we'll be providing all the participants with the software license, basically ANSYS Zimax license to be used for your design project. And all this information related to trial and the submission of MDR and going forward, the submission of the final presentations and everything, all the instructions will be received via email, will be sent to you via email rather. And most of these emails will come from my email. We'll just drop it in the chat. So please make sure to watch out your inbox and also try to whitelist my email because all the instructions most of the time will come from this email. So it might go to a spam sometimes. So please make sure to watch out for all these emails coming from my email address. And some of the information,
Mr.
yes.
Mr. Chandima, if the participant have the question,
Mhm.
they will shoot the email to this address, your address, or
Absolutely, absolutely. If they have any queries, clarifications, feel free to email me. Basically, on the event page, I think we have provided Jim's email address as well. So either one is fine.
Okay, sorry for disturbing.
No
Please
problem
continue.
at all.
Please go ahead.
Yeah, so I was about to say that I'm sure you are referring to our event page on the website. So please keep an eye on the website because time to time we will provide some of the we'll keep updating the event web page. So some of the more important information will be posted on the website as well. But some information, for example, we will try to share the recording of this session with everyone because I know everybody, some of the people actually did not participate. Some of the applicants actually directly emailed us saying they have lectures and other commitments. So they actually asked us to share the video recording, which we will do. So this recording, we might not post on the public website. For obvious reasons, so it will be directly sent to your inbox. So watch out for these emails. But as I said, keep an eye on the website as well. And as Dr. Zaima said, if you have any clarification, feel free to email me or Jim. All these contact details already shared on the email on the event website as well. If you don't have any other questions, I think we are good to close this session for today. No? Shall we?
I think no question already.
Okay, in that case, I think thank you everyone for joining and thank you for registering and participating in this competition. We wish you good luck